Okay, this question is from October number 2017, paper 1-1, question number 8. Well, that's about an hot air balloon falling in an air with a constant velocity, descending with a constant velocity v. And in question, it is mentioned that the W, obviously the weight of the balloon, upthrust because of the air, and an air drag F. Alright? So these three forces are given, and then student has to naturally apply the thinking how if something is going or descending downward in air, the forces can be summarized in an equation. So since the velocity is constant, so acceleration would remain 0, hence resultant force would remain 0. And if F net is 0, sum of all the forces would remain 0. So I can write an equation, W is equals to U plus F, right? This is a situation when it's descending with a constant velocity, okay, where F is a drag force of air. And you should remember the drag force is dependent on the velocity with which the object is moving. Well, where upthrust depends on the surface area of the object, which is constant. W is the weight of the object. Now, if I just make W is equals to U plus F, that's one equation, I can alternatively write U is equals to W minus F, and perhaps F is equals to W minus U. Okay, now the question he's asking that if suppose the same balloon is ascending upwards with the same velocity. Now, before going towards what he is asking in the question, if you just stick at this moment, ascending upward with the same velocity, it means the drag force which is dependent on the velocity would remain same. And velocity is in an upward direction, so the drag force arrow would be in a downward direction. It is F. Okay, now upthrust would remain same because it dependent on surface area. But in question, it is suggested that what weight must be released from the balloon so that it now ascends upward. So it means I have to minus something, alright, so that I would have a value. Obviously, what value I should decrease, or sorry, obviously I will decrease from the W. Some weight has to be dropped down from this balloon now. So I have to the only thing which I have left is the W. I have to decrease some weight, right? I cannot change the U, I cannot change the F. So I only can change W. So now there are options given A, B, C, D. Option A, F, 2F, 3F and 4F. Something like that. So if I start more like picking up by using an error and trial method, if I just select, let's say the first option which is A, the option A which is F. So if I decrease W from the value of W, I decrease the force F, W minus F. Alright, so what is left then? Okay, first of all over here, if I just write down the equation for the upward situation, upthrust must equals to W plus F, and upthrust is dependent on the surface area. In the previous situation, the upthrust was W minus F. Now this time upthrust is W plus F. So in order to make the upthrust same as in this situation, I have to subtract something from W. So let me check. If I subtract W from W, I subtract the force F. This would remain F. So now I have W minus F plus F only left with 0. So upthrust is 0 and upthrust is actually W minus F. It means this is not the right subtraction from the weight. I will cancel this out. I will do it again from upthrust. Let me subtract the next option given to you in B, which is minus 2F. So plus F. Now if I use this minus 2F plus F, I am getting minus F, which is the value actually the upthrust over here. So it means I have to subtract from weight the amount to F so that the balloon will start moving in an upward direction. Alright? Thank you.